here the variable is the base. We've solved problems like this before. The only difference is the power I gave you was a fraction. What does it mean if something is to the 5/2 power? Okay. We have a couple different options. We can either get rid of the square root or the 5th power first. Which one do you guys want to get rid of first? Square root. What's the opposite of a square root? Okay, so those cancel. We get b to the 5th power equals, I do not know 243 squared off the top of my head. Big numbers, yes. How do we get rid of a 5th power? 5th root. Do we need a plus or minus?
Yeah. Maybe not.
Maybe not. When we add radicals, sometimes we do. When do we need a plus or minus when we add a radical? If it's what kind of? If it's an even index. So a square root, 4th root, 6th root, we would do plus or minus. If it's an odd, cube root, 5th root, we don't need the plus or minus. So I need the 5th root of 59,049, and we get 9. And you could certainly check that. If you type 9 to the 5/2 power on your calculator, it gives you 243. So we can always check those. All right, B. What does the 4/3 power mean? Which one do you want to get rid of first?
Cube.
All right, opposite of a cube root is cube. (81 to the 3rd power? How do you get rid of a 4th power? When you add that root, 4 is even, so what do we need with it? That one gets the plus or minus. And the answer there is so this one positive negative 27. Any questions about those, or when you need the plus or minus and when you don't?
No, but what's the rules and period and a couple of others,
Well, I come in for a
how much the one I watched, I about 4. No, some of them were like 4.
All right, you guys do this one. Tells us square root of z to the 5th. You can square first or do your radical. I know most of you square first. I like doing my radical first because I get smaller numbers. But either way, it's fine. Do you have to do a plus or minus on this one? Nope. So if you did the radical first, which I don't think anyone did, but I just wanted to show you. The 5th root of 32 is 2, and then how do you get rid of the square root? Square. So we should get 4. And it looked like we did all right on that one. Any questions on those? Do we need more problems like that, or are we good to move on? Second thing I want you to talk about is inequalities. So, if you are solving an exponential inequality, my recommendation is to make sure that the base you are using is bigger than 1. Okay, here's why. If we deal with a base bigger than 1, we can solve it just like an equation. When your base is less than 1, remember that switches on our graph if it's increasing or decreasing. And so if your base is less than 1, it would actually be a decreasing graph and it will flip your inequalities. So if you don't want to worry about flipping an inequality, just make sure you pick a base bigger than 1. So 3 and 81, that's not hard. What base would we go with? How could you write 81? 3 to the 4th. Okay, so I kept saying your base has to be bigger than 1. This works. If you decided for some unknown reason you wanted to go to a 1/3 power, it would work. You could do a 1/3 power on both sides, but because 1/3 is less than 1, it flips the inequality. So just stick with the bases bigger than 1. So 3 to the 4th is equal to 81. That's why that is legal. We haven't changed our problem yet. So if we go with this, if it were an equal to, we would just drop the base and set the exponents equal. So because it's an exponent and our bases are bigger than 1, we can just drop that base and solve this inequality. So we get x is less than 2. So how would I write that in an interval? Let's look at this. Alright, so if it's an equal to, we can do a base of 1/2. That's just fine. But because it's an inequality, I keep telling you, make sure your base is bigger than 1. So what would we use for our common base? Instead of 1/2, we would switch it to 2. How would you turn 1/2 into a base of 2? What power would that be? 2 to the -1 is 1/2, so I haven't changed my problem. Okay, 1/16. I know my exponent has to be negative. I want it to be 2. 2 to what power equals 16? So I have 2 to the -2x is less than 2 to the -4x minus 12. Because it's power to a power, we multiply those exponents. Now my base is bigger than 1, we can drop the exponents. Okay, I add over my 4x, divide by 2. So x is less than -6. How do we write that? Any questions on those? I want you guys to try one. Actually, let's do this. I'm going to do try that one. See if you can. So if this were an equation, you could use a base of 3/4 or 4/3, and it wouldn't make a bit of difference. Because it's an inequality, which one do you want to use? 3/4 or 4/3? 4/3. With the inequalities, always pick your base to be bigger than 1. So 3/4 is 4/3 to the -1. And that's to the x plus 1. Less than or equal to 4/3 to the 4x minus 4. What do we do with these exponents? Multiply. Power to a power, we multiply. Once you have the same base on each side, you drop it. Okay, so if I am solving for x, I could subtract over my 4x, add over my 1, divide. If you divide by a negative, that flips the inequality. Several of you didn't flip it, so you get x is greater than or equal to 3/5. How do we write that in interval notation? I am going to do just a couple equations like we were working on Friday. I know we had several people out, so probably wouldn't hurt any of us to see a few more of those. First, before I do those, are there any questions about the new stuff from today? So these inequalities, it's using the strategy that we learned Friday, but let's go ahead and do a few more with those equations, just to make sure that we remember everything. So I have 3 here. If we're good with those, then I am done for the day. So if I have square root of 2 to the x plus 1 power equals 8 to the x times 4 to the 3x. Remember, the strategy is to get a common base. What would my base be for 2, 4, and 8? 2. A square root of 2 is 2 to what power? Square root is a 1/2. 8 is 2 to the 3rd. 4 is 2 to the 2nd. Okay, I have not changed my problem. I just rewrote it. 2 to the 2nd power is 4. 2 to the 3rd is 8. 2 to the 1/2 is the square root of 2. So we didn't change anything. We just rewrote it. Now with these exponents, power to a power you multiply. So we get 1/2 x plus 1/2 equals 2 to the 3x times 2 to the 6x. If these are multiplied, what did we do with their exponents? Add them. So all of this works so that we have 2 to a power on each side. Once we get to that point, what do? Drop the base, bring the exponents down. Subtract over your 1/2 x, so 9 minus 1/2 will be 17/2. Divide by our 17/2. And we get 1/17. So our strategy was common base, but you had to have it just once on each side, so you had to do your work to combine things first. Is that one okay? What if I gave you this one? Little bit different because I don't think I did any with the division in the original problem on Friday, but the same general setup. If I'm looking 8 81, 243, and 81. Those are all powers of what number? 9. 81 is 9 squared. Does 9 to a power equal 243? No. So we would have to go down to 3. So 81 is 3 to the 4th. 243 is 3 to the 5th. And 81 is 3 to the 4th. Right? Power to a power, you multiply those exponents. So you get 3 to the 12x plus 8 over 3 to the negative 5x equals 3 to the 4th. If we are dividing, what do we do with the exponents? Subtract them. So you're thinking 12x plus 8 minus negative 5x. So that would turn into 17x plus 8 equals 3 to the 4th. Now we can set the exponents equal. So 17x is negative 4, and x is negative 4 over 17. Do you guys remember these from Friday? Do we have any questions on this? Do we need more? Okay. There is a Math Excel assignment.